Okay, we are live. Enjoy.
Yay, fantastic. Welcome, everyone. Welcome to yet another KubeCon console deep dive. My name is Taylor Dolezal, and I'm joined today by Cody Arkland and Peter McCarron. Gentlemen, welcome.
Hey Taylor, it's like we never left. We're back here again.
So yeah, it's like, can Cody hang out? I apologize. I keep asking your family that. It's great to see you.
He keeps mentioning how fun it is, so I figured I'd just come tag along,
Well, the whole point of console is the fact that you can connect, and so I'm very much looking forward to this. And I'll keep the puns at a minimum today.
For those who don't know Taylor, like he's known for puns, so this was the first of many that we'll drop on this live stream, most likely.
Wonderful. So when it comes to, I'd love to chat with you both about, just it is KubeCon week. There's a lot going on for just about everybody. I feel like I'm checking my calendar about every 15 minutes or so to make sure there's not a meeting I haven't missed. But really would love to, chat with you about Consul 1.9 just dropped recently, and would love to hear about some of the new features that come with that, as well as what's applicable to Kubernetes and some of the things that people might not know exist and that they can get started with.
Yeah, totally. So I think most people who are watching this probably know me from the console space, but those who don't, my name's Cody. I do technical marketing for HashiCorp, and I'm not going to say what product I do because I just bounce all over the place. And Peter, I'll let you introduce yourself real quick if you want.
Hey everyone, Peter McCarron, Senior Product Marketing Manager on the console team. So I am Cody's partner in crime for a lot of this stuff. He makes it all work, and I just kind of talk about it. So that's how we do things here.
Cool. So as far as 1.9 goes, so we're in beta right now, technically, without spoiling anything, I would say keep an eye on how long we're in beta for, because it's going to be a relatively short period of time. But 1.9 is pretty cool. It's a good release. Between 1.8 and 1.9, it's been like a ton of really good stuff coming in. My personal fave, I'm really happy with the observability stuff we've put in. We've, being KubeCon week, we can drop some of the fun names. We've set up some really good first class integrations with Prometheus, so that we can have Prometheus scrape off of console pods, and feed that data back into console. So we've added some new configurations into console that let it say, hey, talk to this Prometheus server, pull your metrics in, and we've added that metrics visibility built right into console, which is cool. As a former operator, and Taylor, you worked at kind of a big company, I think. It's a very common thing. You come in the morning and you log into some of your big systems and you just take a glance, right? Just the quick take a look and see how things are looking. And when you work with a platform that doesn't have that, it's incredibly frustrating. But when you work with a platform that has it and gives you metrics, or good metrics, good context, or the ability to set up your own, it's just I don't want to say value in the cheesy, hey, we're in marketing sort of way, but it's super valuable to be able to come in the morning, see that, and be able to pop in through that throughout the day. Do you have any I'm going to totally hit you with a curveball. Can you think of times in your career where that was valuable, moments that you had?
Oh my gosh, absolutely. Including the big company that you just mentioned. Entertainment's fun. The being able to look at something and have something that is set up for the team before they've even onboarded their applications. I think that was kind of our goal within the SRI team that I worked, was that we would set up these frameworks and these things that you didn't really have to think about, because adoption is really difficult. You could spend all day bike shedding and working through those problems and arguing about or discussing disagreeing about the best way to set up your observability platform, or what trade-offs you want to make. But when that's already made for you and you can just kind of spin up your application into an orchestration area, then you're good to go. And so I really like that. We did that with a lot of our observability and our metrics and alerts as well, because really just taking a look at what's normal and then seeing what diverged out of that space was what was really helpful for us. But I'm really excited to see those observability features that are coming out in Consul 1.9. My personal favorite is the ability to take a look at the latency between the requests and some of the service mesh features that you have.
What's really cool, and we probably won't have time to get into it on this stream. I can seed the ideas and show where the dragons live. We might not be able to fight the dragons, but we can see where the dragons live. We actually have the ability in Consul 1.9 to let you customize this. So you'll see in the demo that I'm going to run through, and I did no slides for this. We're going to stay in code. We're KubeCon. We're going to play with some stuff and build some things here. But you can actually go and you can customize, and you can say, hey, you know what? Like Consul gives us these 4 values by default, but I really don't care about P50 versus P99. I want the P99 value, like, the 99th percentile value. The P50 I can scrap, but I want to replace that with something like current requests, right? But maybe I don't necessarily care about the averaged over 15 minutes that Consul tracks automatically, but I want to see just right now how many requests are hitting this system. You can actually build your own like metrics provider, and it's pretty easy to actually do. Like I try to be very careful with when I use the phrase easy, because what's easy for us might not be easy for everybody, just like what's easy for them might not be easy for me. But we give you a good set of template to build off of to show how to kind of construct this out. So I love good visibility tools in platforms that you can like go in and see stuff, but I love even more when they make it easy for me to customize and grow it and shift it in my own way. I think that like when people acknowledge the ecosystem and acknowledge that not all of us have the exact same goals and priorities, that shifts is a really good thing for a vendor to do. So I'm proud of our engineering team. They did a lot of good work on this. A guy named Paul Banks on the team. He's on Twitter. Find him. He did great work building this out, as well as the rest of the team. But like Paul kind of spearheaded a lot of this.
Awesome. And Peter, is there anything that you're looking forward to in 1.9, or do you have any musings or thoughts on some of the things that we were talking about before?
Yeah, actually, Cody kind of stole mine because I was going to say observability too, just because I do think it's cool seeing graphics, right? Everybody likes visuals. But no, like actually, one of the other ones I think is really, really impressive and I'm super excited about is Appleware intentions. So just being able to have that kind of granularity and control. Like, when we introduced intentions, I think people thought very like from a basic concept, it made sense, right? They're like, okay, I want A to talk to B. So therefore I can stipulate that A always talks to B. Well, there's different ways of talking, right? Like there's different forms of communication. There's different forms of like kind of requests. And so being able to get a little bit more granular with that to say like, okay, I have this database, but I just want this API to be able to pull information from it, right? I just want GET requests to come through. I don't care about like, I don't want it to be able to delete anything. I don't want it to be able to post anything there. I just want to be able to have it receive information, and actually being able to control that, I think is really powerful for people. And that as we start to move and more people start to kind of trust service mesh to build, like be a part of their production environments, like having those kind of little tiny details will make it that much easier to trust a system like Consul to be able to help. So I think that one's super, super cool. Close second behind observability. But yeah, in general, like 1.9's got so many cool tidbits in it that I really hope people go play with it. As Cody said, keep an eye out sooner rather than later if you're waiting for GA, but beta's out there right now. I definitely recommend checking it out.
Yeah, and it wouldn't be KubeCon if we didn't mention so like we've introduced CRDs in this release also, so the ability to control traffic policies around Consul in a Kubernetes native way. It's the first like run at this, so we've got a good set of like I would say a healthy set of these like CRDs in place for traffic management, and it's only going to grow. Like I've seen some of the stuff for Consul.next. There's more being added on there. So what we did this time is we really built this good foundation around what we needed to kind of accomplish now, and we're going to grow that out as time goes. So ZRDs are also really, really cool, and you'll see me deploy. I'm going to go through what we're going to end up doing in the demo, is stepping through kind of the Helm chart that's going to deploy this. We're going to deploy it out onto GKE. And we'll go through that Helm chart. We'll pick out some of the values and explain what's going on, and you'll see where the controller is set up at. So
don't forget, Helm chart supports OpenShift now too. So
for our Red Hat fans in the audience.
I've heard the road to Helm is paved with good intentions, so I'm very excited for these for these demos today.
That feels like a Helm V2 reference. It feels like a V2.
That's a great point. For those of you that aren't aware, Helm V2 it gave a send off this week, and so we bid thee well, Helm V2. If you haven't upgraded your charts and everything to V3, I highly recommend doing so because V2 is gone and all of the charts have moved. I saw a little bit of commentary on that over Twitter this week, so be sure to check that out. But wonderful. Well, I'd love to turn it over to you, Cody and Peter, if you want to kick things off here with our with the demos.
Yeah. Give me 1 second. We'll get spinning. We're gonna jump right into command line. And as always, Taylor, more so for everybody else in the audience, like please feel free to stop me along the way. You see anything you want to dig in more on. I love digging in on this stuff, as Peter can attest to. So we should see my my terminal window, right?
Looking good.
Awesome. So we had a bunch of stuff in here. We're not going to mess with all of it. There's a few things that we're going to touch. We'll do a kube control git pod, see what we have working in here. Hopefully I haven't broken anything. Cool. So I have so we're going to do a waypoint stream tomorrow. So to, we'll call out. There's a waypoint server in here that's running an application that I built that's got some really cool new features in it. So tune in tomorrow for that one. But other than that, we don't have anything in this cluster. Let's make sure I don't have any PVCs in place. If you're like me and you're playing with Consul a lot, you oftentimes will end up having some dangling PVCs in there. So make sure you clear those out before you do another deployment, or sad things will happen. So we're going to go in, we're going to take a look at Consul Helm, and we're going to hit our Helm chart. So this is our Consul Helm chart. So the Helm chart, for the unindoctrinated, the Helm chart is a really shortcut way to do a bunch of like complex install stuff. So we have these stanzas inside of this Helm chart that dictate how things are configured. Because I'm on the inside, I get to run some dev hotness. So a little bit more bleeding edge than most, but not too far behind. I think we're only like one version off. I've set it up to run three replica nodes and expect three. So what that tells Consul is, hey, don't actually start trying to serve traffic until 3 nodes come up and join each other, and that quorum is actually built up. Sorry for the World of Warcraft announcement in the top corner there. Make sure that closes down.
It's just all part of the demo.
It's all part of the demo. It's all part of the demo. And here's where some of that stuff I talked about, the new primitives that we added in, come into play. So we've got this extra config stanza. And what this does is let you feed in some of the extra configs appropriately enough. We've got UI config. We enable the UI. We take a metrics provider and we tell we're going to use Prometheus. So that means Consul's expecting the Prometheus styled the Prometheus styled metrics. And we're telling it to get that stuff from here. And we can just call it Prometheus server because we're reaching out within cluster. In my environment at home, I have multiple Consul clusters that talk to that actually federate to their own Prometheus instances. And then I have a Prometheus kind of main cluster that scrapes all of them. So I changed this value to that one so that I'm referencing like this master one that has all the stuff. But you don't always have to do that. In my case, for this demo, we can keep it simple and keep it inside cluster. We've got load balancer turned on. We're enabling the controller for the CRDs. So this is what will automatically deploy the CRDs. We're turning on connect inject. So connect is what the Consul service mesh functionality is called under the covers. We generally refer to it as just Consul service mesh, but if you inspect the code, it's called Consul connect. We turn on central config, which is just a feature of Consul. It says, hey, store some of the configurations in the central config store and let it distribute out everywhere. We set a proxy default inside of there, which says, hey, every pod's going to have this 9102. So check that for Prometheus data. And then we get an ingress gateway in. I actually need to update this because we're deploying onto GKE, and GKE does not like when you try to do a port 80 for that. So we're going to correct that right now. So we'll head down here.
I had 2 questions for you, Cody. One
Shoot.
was one that was asked in chat by Zaid. Was if the demo resources would be available afterwards.
I can certainly make them available afterwards. Absolutely.
Awesome. Thank you so much. The other question or note was that the terminal was just a tad bit small, and not a problem. And that's all I've got for you now. Keep the commentary flowing, keep the questions going, and I'll be sure to. That's what they pay me to do, is butt in and interrupt Cody and Peter. So please do not stop the questions.
Yeah, and Taylor, I might cut you off on a couple of those and try and ask a question ahead of time.
Yeah, excuse me. Sounds good.
Without diving too deep into this, we're also going to deploy out the Prometheus Helm chart here as well. I don't think we need to unpack that too much. It's pretty straightforward. We just need Prometheus in the cluster to scrape the stuffs. So we're going to do Helm, install. We'll go prom. So you see we're hitting my GKE cluster over here. Helm install here. We're going to go ahead, because we're going to do a few things in a row. We're not going to wait for it. We'll trust. We'll trust that things go the right way. So give that a moment. We're also going to install Vault. So I'll unpack a little bit of Vault stuff in this as well. So we'll just do a kube control get pods real quick. Everything is very ugly because we've made it really big screen, but it makes it easier for the folks on the stream to watch, and that's what's more important. So prom's still coming up. Let's do a little watch action. So wait for that to go to 2 of 2. Should happen here in just a moment, which is, I guess, kind of the same thing as doing dash dash wait. So I didn't really save us any time. All right. We can actually just go ahead and start the console install. So I'm using that console config that I showed a moment ago. So we'll do helm install console, and I have kind of my stuff pathed out already. So everything's looking pretty good there. Just double check everything looks good. Cool. And I'll drop the weight off because there's a couple things. We're gonna have some fun here, and I'll start to unpack some of the stuff that happens under the covers. A lot of times we don't get to do this on some of the streams. We end up just doing the demo and saying, hey, everything's working. But like, I like to show people how the wrenches turn, how the knobs are turned underneath the covers at times. So we'll do a kube control get pods there. So we see the controller and webhook cert manager are coming up. Those are obviously very important components of each other to be able to do like the certs inside of the actual console cluster. And we can see these console server nodes are starting to come up. So let's grab let's grab console 0, and let's do a kube control logs against console server. Let's see what we got here. Now I am going to zoom out just a little bit for now. I'll get back zoomed close in a few moments here. So let me redo this now so we can hopefully get a little bit better. Cool. So we can see a lot of stuff is happening in here. Basically, long story short, what's happening is console operates in a distributed manner. So it operates as a quorum. So what it's doing here is it's bringing up each of these servers and it's waiting for each other to come online. Since we've done this inside a kube, it can use service discovery inside a kube to find its other server members. So once it finds those and it finds 3 that are up and giving good heartbeats and health checks are passing, it joins them into a cluster and has them say, hey, we're ready to go. So in a few moments that should come up. You'll see this error message popping, no terminating gateway or ingress gateway associated with this gateway. That's because we haven't applied the configurations yet. So right now we have an ingress gateway that's deployed into the cluster, but console doesn't know what to do with it because it doesn't have the configuration. So really it's just spun up a pod and a service and it's just hanging out there saying, hey, I don't know who I am or what I am, but eventually you'll tell me and then I can do stuff with that. So we can see good stuff happening here. Everything's up. We got 202 on our prom server. We've got our console environment. So let's do a kube get services. See a whole bunch of noise in here. Let's find the UI. There we go, port 80. Now it's important to note, I'm running this in a insecure configuration. So what that means is that there's no ACLs in place. There's no TLS on like the user accessible side of it, which means that people on the stream could pop into this cluster and do stuff, which please don't, or do, have fun with it, live your dream. That being said, the cluster's up. We can see 3 nodes, everybody's healthy. We're getting all these nodes in the environment. I hit nodes here. We can see them here. I got 3 server nodes. I've got 1 agent node per worker node in the environment. So in a typical console environment, every node that you have deployed has its own agent running on it. So if I deploy 4 VMs, I have 4 agents. In Kubernetes land, this paradigm gets kind of flipped on its head, as you know, Taylor. When we drop, you might have a single node in Kube running 10 services, 15 services, depending upon size, could be even more. In Kube, it just needs that 1 agent living on that node itself. The pods all will talk to that agent, and that agent will surface what it needs into the cluster. So it's a little bit of an architecture difference versus the traditional like virtual machine-based environment, whereas it's 1-to-1 on the VMs that you deploy. You might have multiple things running on that VM, potentially multiple services, and those are talking to the agent. Same paradigm as Kube in that case, but typically it's 1-to-1. It's more commonly what we see. Oh, so let's have some more fun here. So we've got our app. Let's see, chat app. Yeah, I lost my train of thought there for a second. Whole lot of stuff happening in here. We've got, first and foremost, we've got 2 CRDs in place. Because we're working in a service mesh, we're working with Envoy. Envoy understands there's a difference between TCP traffic and a difference between HTTP traffic. Ultimately, HTTP flows over the same pipes. We all know this. But Envoy can do some special things when it's HTTP traffic, namely can understand some of these actual web requests and understand what's in like the header and start to do a little bit more inspection on what this traffic is and what it can do. So in this case, we tell Consul, hey, the front end service and the API service are both HTTP based services. You can do more with these. They're going to give you that data. Spin up an HTTP listener and listen to those. We have a database that deploys also. If you try to make a database into an HTTP listener, everything's going to go sideways. It's not going to work because that's not giving HTTP data out. It's giving TCP data, in this case, Postgres, so 5432, right? So in this case, we set the CRDs for both of those. And those are stored as part of the deployment. So I don't have to go in and configure those manually, kind of like what I have to do with the ingress gateway, where I have to go manually configure that today. That's one of the like higher priority CRDs that are coming next. Scrolling through a little bit more, we have this pod deployment. For anybody, I always get this question, so I'm going to answer it as a side tangent. If you're interested in having like the colored cat, like I have here on the screen, where it does syntax styling and all that, that's a program called BAT. It's available on all over the place. So BAT will get you this. And what I've done in my environment is I aliased out cat over BAT, which is super confusing to say out loud, but it does give me pretty graphics, so I'll deal with the confusion. I'm deploying out a pod database, or database as a pod. I'm telling Prometheus to scrape it, so Prometheus is going to gather metrics around it. I'm also telling it to go ahead and do the console injection on it. So telling it, say, this is a service mesh service. Let's go ahead and inject the sidecar on it. So it gets an Envoy sidecar running alongside it. We're doing a deployment. Oh,
Really
was
quick,
that a question?
Cody. Yeah, I had one question. The question was on VMs, is it one console agent per VM? But in Kubernetes, it's just one pod that contains the agent. Would you mind kind of going through it, just like it's typically, my understanding, it's typically like per unit of compute that makes sense.
Yeah.
But
so let's draw this out as kind of little scenario in our head for a second. So we have 4 VMs and we have a 4-node Kubernetes cluster. On the 4 VMs, you're going to have an agent installed on every one of those VMs. On Kubernetes, now your Kubernetes cluster, when you do a kubectl get pods, you might have 50 pods on there across those 4 nodes. You're going to have 4 agents running. It's going to be 1 per node, and that 1 per node can service multiple pods living on that same node. So if you have an average of 15 pods per node, just as a random number, all of those 15 pods are going to be talking to that one agent for that node. If you scale that cluster out and it becomes an 8-node Kubernetes cluster, you're now going to have 8 agents living on that.
awesome. Perfect. Thank you, Cody.
Solid. We do a deployment here for, again, the uninitiated. A lot of first timers at KubeCon. Welcome. We love you in the community. Thanks for coming and hanging out at KubeCon with us. We do a deployment here so that we can control scale. So we can scale this out. A pod by itself is just a single unit, smallest unit of compute in Kubernetes. But a deployment lets us say, hey, how many replicas do we want of this? So in this case, I'm doing 1 replica, but I have the ability to scale this out to like 3 replicas if I want, or 10 replicas if I want. So I do a deployment so I can control the scale of this. We also add some annotations here as well. So again, we're scraping for metrics. We're telling Prometheus to go do its thing. And then we have a couple of new primitives here for Consul, where we're saying, hey, we're setting a metadata version. We're not going to use that today. I use that metadata version for when I do traffic splitting. So if I want to say, hey, send 50% of traffic to V2, 50% to V1, that's why I use that metadata version. We're not covering that in this demo, but that's why it's there. We're setting that as part of the annotation. So when the pod comes up, it has that metadata associated with it. We're telling it its port. So the port for this API service is 5000 in this case. It's Python Flask server. Shout out to all the Python fans out there. And then we're setting up some upstreams. We're telling the API server, you're going to talk to a database on this port, and you're going to talk to Redis on this port. Congrats, I found a reason to use Redis in my demo.
Ping pong, yeah.
right. And so we pull in what a pod it is. And now there's something interesting happening right here. And this is kind of a part 1 of 2 thing. I've got a bunch of environment variables here that I'm feeding in, and these are all static. Like, we don't like this. This is not a secure way to do things, but it probably happens more than we'd like to admit. We are going to filter this out and swap over to Vault here in a moment, where we will have Vault kind of dynamically configure these for us on a V2 of the deployment, assuming I can talk faster. But for now, that's why these are coming in. These give our Python application the ability to actually connect to the database.
Hey, Cody.
And then we have a front end service. I'm not going to go through the whole thing again. Same concepts. Front end talks to APIs via an upstream, so on and so forth. Same thing for Redis. We're deploying Redis. Just nothing much more to say about that.
Hey, Cody, you had a question come in. Just asking in general about like, so the question was about, is there anti-affinity so that agents are always on different nodes? So maybe just talk a little bit about like how we handle affinity with different nodes.
Yeah, in the case of Kube, the system handles that for you. So the system says that it will put an agent on each node. It spreads them out. There's an anti-affinity that comes into place there. I might be losing the term, so Taylor, correct me if I'm wrong. Daemon set, right? Daemon sets guarantee separate pods or separate worker nodes. So yeah, so the daemon set that gets created to spread out the agents.
Correct.
So deployed the app. We do a kubectl get pods. We hope that nothing broke. All right, everything deployed. Fantastic. So this is all up and running, but we don't have any way to get into it. If we do a kubectl get service, we have no service because I didn't do one inside a kube. Again, for those uninitiated, in order to expose a Kubernetes service outside of the cluster, got to create a service. Got to throw either a node port or load balancer in front of it. We don't have that, so no accessing. What we do have is an ingress gateway, though, in Consul. We can configure that. So I'm going to grab the config, which I have right here. I'm going to copy it. I'll show you guys the config when we get inside of the VM. We're going to exec into the Consul server. I could do this in a couple different ways. I could apply this with Terraform. I could do it via the API directly. In a demo, it's easier to show if I do it this way. So here we are. All right. It's an ingress gateway. It's listening on port 8080. It's an HTTP service. Remember, we set that to the service defaults earlier on. Going to the front end. Going to the front end service in Consul. So we'll do a Consul config write. Should get a happy message back. Fantastic. Oops, words are hard. They don't know us anymore. All right, so that's up and running. So now if we do a kubectl get services and we go and hit, actually first we will go into here. We'll go into services. We can see all our stuff came up. We go to the ingress gateway. We see ingress gateway is put at front end. We're saying unable to load metrics right now because nothing's hit the service yet. So it's just empty. So it can't load things that don't exist yet. But we can see kind of a topology view. This is new in Consul 1.9, this view of services and the mapping between them. This is super basic, so it's not super exciting. For us, it's really exciting because this wasn't here at all before. So it's like things are much better now. When you have a lot of services, this really starts to shine. So say you have a different type of front-end service that's using a common API and hitting a couple of different backends, that all shows up here in a really clean way. It's really useful. I don't have it set up in here, but if we go in and we hit this configure metrics dashboard, it's actually templated. So if you set it up right, when you click this, it will open up a dashboard for the API service, for example. So if you templated out, or if you created them in the right, like using the right names, it'll hit Grafana and pull that up. So shout out to Grafana. Good stuff there. So now we will go back into Kube. We'll grab our ingress gateway service running on port 80. I got to drag this over onto here. Actually, what I'm going to do so that we can keep some sort of organization. Boom. This is like a demo application I use often. It doesn't really matter much what's being shown here. We can see that I have connectivity to the back end though. So the way this application works is I have a front end that's written in Angular. So that Angular front end is talking to the API tier. That API tier is talking to both the Redis backend for message queuing. So when I do a post into this, it'll go through, it'll send a job to Redis and let Celery process it. And then ultimately that data gets injected into the Postgres database. So just a little 4-tier thing that does stuff. In this case, we're talking over service mesh now. All of this communication is encrypted over MTLS. It's secured. It's controlled and managed from within the service mesh. That database connectivity is using those environment variables. So we're about to shift into gears where we're going to deploy Vault and swap that out. But first, let's have a little bit of fun with maybe getting a little bit of load testing against this. You've seen me do this before, I think, Taylor, where I bring up Celery. So we're going to use Locust. We're going to use Locust to actually do some load testing here. So we're going to go into this Locust experiments folder in the Kubernetes. We're going to change this out. Oops.
And I've got 2 questions for you before you hit the big red button on the load test.
Okay, I'm going to go ahead and start this deployment so you can talk while it deploys.
Perfect. If the one question is, if the console service is TLS secured, where does the TLS termination take place?
So within, there's 2 ways to answer this. Within cluster, termination takes place basically at the service or at the Envoy sidecar that lives alongside whatever service is in place. We do have the ability to do what's called a terminating gateway so if you wanted to bring a system that's outside of the service mesh to be part of the service mesh. Great example of this is you want to use like Amazon RDS as a database instead of Postgres. You drop a terminating gateway in that VPC. In that case, the termination would happen at that terminating gateway, and then standard TCP or standard like regular traffic would happen from that gateway to the RDS instance. You can actually carry that MTLS all the way through to the service. If you have like the endpoint certificate, you can load that into the terminating gateway, and the terminating gateway will kind of pass that traffic along and maintain that secure encryption. But that's a lot of people, that's like an extra step that not everyone does. They should, just to be clear, you should do that. But if you don't, you can use terminating gateway to get pretty darn close to it, kind of that last 10 feet before it'll reach out and touch somebody and hit that service, not over the MTLS. But within cluster, the envoy to envoy communication is where that MTLS happens. So it all the way to the sidecar, and the sidecar is bolted directly to the service anyways.
And you said the magic word in reference to the next question, which is, so if every node has a console agent, do we also need to inject a sidecar with console inside the pod too?
So the agent is just facilitating communication. Like what the agent is doing is passing that configuration data down to the sidecars. So ultimately, no, like the agent is not, the agent itself in the truest sense of the word is not part of the service mesh. It doesn't have an Envoy sidecar running to do its work. It's an agent node. What it is doing is it's passing that control plane data from the servers down into those Envoy sidecars. So those don't need that, and that's all handled automatically. Just to be clear, like you're never going in and configuring this stuff manually inside of Kube. The Helm chart's doing all of that for you. But the mesh services that have connect inject enabled get a sidecar. The agents are just passing data around. They're your friend who brings donuts to your workplace in the morning when COVID isn't a thing. They hand out the donuts. They don't eat them because they're on a diet.
It's the best sidecar ever. Thank you, Cody.
Best sidecar. Is that good answers?
Absolutely. You got a thank you for the very clear answer in response. So thank you very much.
Fantastic. All right. So the sample code for Locust that I got here doesn't actually give me a load balancer for Locust. So I have to do a kube control port forward. So we'll do a kube control port forward into our Locust master node. So that is up. We'll switch back into here. We'll do we're pointed at here. We'll do just a quick sim of 100 users at 20 users at a time. Nothing crazy. Requests are going through. If we pop back into console in a few moments, sometimes it takes a few for the metrics engine to kick in on the first time because it starts scraping. So it's started to scrape now, just hasn't registered anything for the initial run. So we go into API, we can see it's starting to pull up. We're just waiting for it to start actually registering, but these values on the bottom will start to populate based on the traffic that's coming in. So in this case, we'll get requests per second averaged over 15 minutes. We'll get error rate if there's any problems. We'll get latency, the 50% average latency over 15 minutes, as well as the 99 percentile latency over that time. So just waiting for it to load up. Just taking a few. So we don't need to sit here and wait for that the entire time, but you can see kind of the overall concept that we're going for. So Locust still running. A couple of fails popped up. I must have broke something in there during that little run. So we'll stop traffic. In theory, we should get some error messages here directly inside of the metrics read. So while we wait for that, let's go ahead and move on to the vault portion of getting this squared up. Note that we don't have any intention set up, so everything's allowed by default. If I go in and do a default deny, the entire app will break. So just heads up on that. So let's see, we can close Locust for now. We don't need to worry about that. We've got our connectivity here. Everything's good. If I go into this messaging tab, you can see a whole bunch of messages come through. And actually what I can do is I can go API health, oops, not API health, posts. We can see in those few moments, we got 1,500 posts into this database, all saying the exact same thing. So things were churning. So let's make some changes now. Let's get Vault going in here. And what Vault is going to do for us is let us actually have a secrets injection into those pods. So specifically into the API tier. Kind of what the flow is going to look like here is that when that pod comes up, it's going to check in with Vault and say, hey, do you have some secrets for me? Vault's going to say, yes, I do. And it's going to inject into that pod those secrets. So you're not statically setting environment variables badly. So back out. And we'll do Vault values. Super basic Helm chart, lot shorter than the console one. We're doing a standalone, so kind of like a dev mode where it's just a single node that spins up. Turning on basic configs for Vault, giving it a service. We'll get a load balancer out of that as well. And turning on the injector so that when we have the annotations in place, it injects the secrets into the pod. So the theme we're going for here is securing both the connectivity aspect of the application, so MTLS and all the service mesh goodness, as well as securing the application context, so how that machine-to-machine credentials are passed between tiers. So it's that whole zero trust concept that everyone slams on marketing material all day long. So we'll do a Helm install. Let's see, what is it? I think I did. Let's go through, make sure that I get the right one here. Here, cool. But this is a little different. That's Vault values. Fantastic. So that is going to deploy. Now the configuration for Vault is a little bit different, not extremely so, but because there is some like initialization that has to take place in order to kind of get us some better security. We do have to initialize the cluster, and we do have to kind of inject some configs in. It's really quick though, and I have them all handy set up on my little notepad off to the side here that I will copy paste into the window and explain as we go, obviously.
Hey, Cody, you had a question come in just asking about basically how does a sidecar get put into a pod? Looking for a demo, but maybe just like quickly talk about like how sidecars get deployed inside a pod.
Well, so there's it's a pretty nuanced question because there's a lot of things that happen there. In the Helm chart, when you do that connect inject true, the Helm chart has directives in it that say, hey, when you see this annotation, also do this stuff as a sidecar resource. So like the Helm chart is what dictates, hey, when you see this annotation, do this. And that sidecar ultimately gets deployed as a sidecar resource for that one. So it has a specific set of configs. It's mounting a specific set of configurations from that's receiving from Consul as part of that, and it's being just configured as a sidecar agent. The translation here you can think of is when I do this on VMs, I install Consul on the VM. I build a service for it. So I do systemctl start Consul, and Consul's up and running. I then pull down the Envoy binary and I create another service for Envoy. And I do the exact same thing for Envoy, but I point it at Consul at the Consul agent locally. It's the exact same thing, with the exception that instead of living as two services on one VM, it's two pods that are connected to each other as a sidecar. So they are bound to one another, like Frodo and the Ring. They are bound, and they live on that same node with each other. So it's similar to the VM process. Just the break point is it's two pods that are intertwined, living on the same node. Does that pass the Kubernetes explanation good enough, Taylor? Do the judges allow it?
Yes, and the bonus points for Lord of the Rings reference. Really appreciated that.
As long as you're now that like the was a kubectl to lead pods is like throwing it into Mount Doom, right?
I mean, yeah, you're not wrong. So yeah, we've execed into our Vault pod. So we'll do Vault operator init. This gives us a bunch of configs. I'm going to stash these off to the side because I will need those in a few moments here. We're going to export the Vault token environment variable. Try and copy and pasting off to the side. And then we're going to do Vault operator unseal. So Vault needs to the Vault needs to be unsealed in order to do stuff with it. So I've got the first one. We get 5 keys. It accepts 3 to unseal it. Don't share these keys with people. Don't put them on a stream and share them with everybody who's at KubeCon watching the stream. It's not a good thing to do. Fortunately, this cluster will be gone soon enough. So this is unsealed now. It's available to do stuff with. So what we'll do now is we're going to put some of the configs in for automatic secret injection. There's 2 types of secret injection. Well, there's more than 2, but there's 2 primarily that you can do. There's static secrets, which you store a value in Vault and it pushes it into the cube. And then there's dynamic secrets, where Vault will actually run like a command to generate a password and then use that as the dynamic password. So this is super useful for databases because you can have like a Postgres user created on the fly that has credentials and then expires after about an hour. And then Vault will automatically restart that part of the pod and inject a new secret. That one's the preferred path. We're not doing that today. It's just a little bit more involved. We're doing the static one today. Anything's better than environment variables. Do something other than environment variables. That's Cody's takeaway here. So first and foremost, we're going to write a policy out. This policy has access to the secret path and it has read access. So that is done. Oops. No, it's not. I lied. We need to give it the EOF. There we go. Cool. We're then going to write this policy into Vault. So now it has an API policy. We're going to tell Vault to enable Kubernetes auth, which means that it's going to talk to Kubernetes for its authentication parameters. We are then going to configure that authentication. So we get the actual JWT token out from Kube. We get the certs for Kube, the host for Kube, and we basically inject those into Vault and say, hey, these are the configs. And then we set up our actual service account. So service account is expecting a service account named API. For the default namespace, it's getting the API policy that we created up here. And it lives for an hour. We are then going to enable the secret engine. So we'll do Vault secrets enable. We're going to give it a custom path of secret, and that is intended to match this up here, that secret wildcard up there. And we're going to use the KV secrets. We will then put a secret in, and I'm just going to copy and paste for the sake of easiness. We inject in our secrets. So we have a Postgres secret, our username, Postgres, password, Postgres password. Super complex. No one would ever guess that. It's written to this secret path. That's going to be important in a little bit here. So we're done with the command line now. We can back out. And what we'll do is we'll grab the Vault actual address again. Come in here. We'll do HTTP. Oh, look at that's pretty. Hello, friend. We will log in so we can see our secret here, database, and our credentials are stored here. So all that stuff worked. We're also using the root credential to log in, which is bad, but again, we're demoing, so we're living life. I have we'll make a quick change to our actual application. So we're going to go app.yaml. And actually what we'll do is I actually have this set up in the app v2.yaml, and we'll just use that one. There's not much changed in there. What I've done in here, though, a couple small differences. I have created a service account called API. So it's a Kube service account to allow communication. We add that service account to here on the bottom of the API pod. We remove out all those pesky environment variables and we add a whole bunch more annotations. So we're telling Vault to inject its secret sidecar. We're telling it to inject a secret from this path. We've duplicated some of this here for some reason. I don't know why I did that, but we're here now. We're telling it to use the API role, which is the service account we created earlier. And then we're giving it a template for the secret. So what we're doing here is we're saying, hey, with the secret that we got from secretsDB, fill in this value within the pod. And I'll actually show you how this gets filled in. What we're going to do, though, for fun, is we're going to break it first. So we will go vim app v2.yaml, and we are going to come in here, and we are going to replace the service account with Taylor. Created our API service account. We reconfigured our pod. And I think I need to actually remove that pod in order for it to do what I want it to do. We're going to double check. I think I actually have to kill that pod off. It's redeploying the front end there, which is fine. And it's, okay. Because that had multiple in it, so I got to fix that real quick. We had a small hiccup there. Let me go back in here and edit this out, because what this had was multiple of these here. So what we do is we're just turning that down to 1 for now, just for simplicity's sake. And then the same thing we will do for the front end. We'll set that back to 1 as well. Wouldn't have broken anything. It just would have created a whole bunch more pods that I don't really need in the environment.
Yeah, we already did the locust load test earlier, so didn't want to duplicate that.
We lost Peter, so I'm suspecting he lost power again. He lost power a little bit ago. So, all right. So this is coming up. We can see this has 4 now. It's odd that everything has 3. Or all of the other services has 3, but this has 4. I wonder why. That's because this one has now a Vault sidecar. So if we go klogs against that, we're going to get a prompt back that, hey, you got to tell me a little bit more specific what you want. We're going to use Vault agent init, and we're going to see some errors in here as expected. We gave it the name Taylor, but it doesn't know Taylor. Not like I do, at least. So it's not going to work. This needs to match the service account that you've created in Kube, and that service account that matches in Kube needs to be the one that you defined in Vault as well. They need to be consistent in order for this to work. So we're going to go at v2. And as much as I like you, Taylor, I'm not trusting you to give me access to my secrets. So I'm going to switch this back to API.
Ah, darn it. Well, can't win them all.
Can't win them all. So we're going to update this. Now we have a bunch of these running in here, so it's hard to tell which one we actually want. There we go. So that is doing what it's supposed to. So if we do this now and we go vault agent init, boom, looks much happier. So what it's done is it said, hey, I have access now. I can get this. I'm going to write a secret out to this location. And here we go. We'll pull back the curtain again. So we're going to go kubeexec. This is just a shortcut, an alias shortcut I have locally for anyone who knows. Just kube control exec, TI for interactive. Oh, that's what you get when you highlight things you didn't mean to highlight. There we go. Typing is hard. All right. So what this does is write it into a file on the local system that can then be read from. This would same thing would happen with the dynamic secret. It would just constantly change it as needed. So this is stored in there. You can only get this if you have a level of access to exec into pods, which hopefully you're guarding with your life anyways. But this now in my application, if we take a look at my poorly written, we take a look at my poorly written Python code here, we can see that I actually have a catch here for if this is available, pull it in as a file, read it out as something we can use in our content. So we build our connection string off of that. So now if we go back into our application, we should have it should be successfully connected. And ultimately now it's going to be using, it might have a little bit of a problem because of, oh, no, there it goes. So it is now connected to that new pod using the secure credentials from Vault. So we're managing our secrets in Vault. If we change that, any new pods are going to get the updated credentials. And we're also able to secure this all inside a console using our service mesh capabilities. So life is good. Life is good. Things are still coming up over here from when we cycled out some of those pods. So we just have to wait a little while for console to finish updating there. This is what happens when you run a very small deployment as opposed to doing everything in the proper HA way. But that's it. That's our journey. So we went from having nothing in place to having console up, meshing services between kind of a four node deployment, all the way up to having Vault in place as well and securing connectivity between those tiers. So not bad for about 40-minute journey.
Absolutely. Yeah, you covered a lot of ground. I'd say I'd consider this a fantastic day if we can get all those things done with some applications. So.
How are we doing on questions?
I think we're looking good. If y'all have any questions, please feel free to ask. I know we answered a few while we were working on the demo, but yeah, if you have any more, please, by all means, raise up some questions. Yeah, I'd say I'm very excited to start to combine some more things here. One thing I'm really excited about, Terraform holds a very special place in my heart. And being able to work with, I'm blanking on the name of the feature for console, but being able to use Terraform to kind of do those live updates and everything on that front is something I'm also looking forward to as well.
Yes, so the network infrastructure automation.
Yes.
So we have this functionality in for the people who don't know, we have this new functionality in console that says, hey, like if you're registering services in console, you're probably needing to update those on firewalls and load balancers and stuff in the back end as well. And we have this kind of marrying between console and Terraform now that says, hey, we can have Terraform drive these updates based on console definitions. And that's this tool we have called Console Terraform Sync. And what it does is, like I said, it looks at the service data and says, hey, you have 3 nodes here, and I don't see those in firewall over here. So as long as you've configured that definition and you have that Terraform run set up, it'll take that and run a Terraform apply to update that remote system. And it's doing this constantly. So it's a synchronization effort where it's saying, hey, I need to make sure this is constantly being updated against my source of truth. So the firewall is looking at Consul and saying, hey, I trust that you know everything that needs to be registered here. I'm going to update you. I'm going to update my systems based on you accordingly. It's a little bit less of a, I wouldn't call it at all a Kubernetes story whatsoever, but it is absolutely relevant for like network admins and system admins who are typically doing like very annoying long firewall requests to do stuff like allow the system to manage itself and properly document as needed, right?
It's really fun and fascinating. I think some of the there's a joke that I heard about edge computing and people who work in those spaces, and everyone's worked with on-prem before, and know the cloud right now. I've heard people that work in on-prem say, "Oh, just call it edge computing, and it's cool again." And people want to work on it, which is really fun. But I like seeing a lot of context where people will use Kubernetes in the cloud or on-prem or at the edge and kind of connect all these things together. I think those are some of the most unique and fun workflows that I've seen on that front. We did just get a question in, and it is, can I use AES keys to encrypt the password? And does Vault handle rotation of the AES keys as also in-memory injection of the password into the application? So
yeah, so this we actually got this question kind of through back channel about this, and it's a little outside of my deep expertise. And I checked with one of Taylor's counterparts, Rosemary, who informed us that we believe it's possible if you're using like the transit secrets engine. You'll have to have your app call the Vault API to get the new secret, but then we believe it is actually possible to have that done for AES secrets in the transit secrets engine. So it should be possible using that. And then you'd have, like I said, you just have to handle, like there's not an automatic rotation of that to have like Vault automatically rotate that like I did in this. You'd have to have your app call the API to get that rotated key and pull that back in, or as far as like keeping it in memory at least.
Awesome. Thank you. And what about using Consul for Vault and any other services running on the cluster? Is it possible? Not recommended. What are the risks? My dog clearly has a problem with that.
I thought somebody barged in on our stream for a second. I was like, are we getting pranked? So for background on this, I think I know the question that's being asked here, just unpacking it a little bit more. I think this is being asked because historically people have used a Consul as a backend for Vault data a lot. So they'll store basically like the key value store for Vault would be Consul. And we do this for big scale because Consul scales very, very well. That's changed as of recent, and now Vault has integrated storage. And that's the reference architecture preferred path to go, is to use the integrated storage for Vault. I think the question was asking if you're using Consul for the backend for Vault, should you use it for other stuff, or can you use it for other stuff? Can, yes. Should, probably not. It depends on how much your Vault's getting hit. Now, the book, like the book of HashiCorp says, thou shalt not use this. Cody, the operator, says that if you have like 2 apps using Vault right now and you're getting very low traffic, you'd probably pull it off and like the world's not going to end. The thing is, when at scale, when you have Vault managing credentials, it gets so many endpoints. There's a lot of read-write traffic that's hitting the Consul key value store and a lot of like the Consul backend databases. So it becomes a high risk, not from that specific traffic, but more so from the amount of volume coming in and like trying to co-locate that with service mesh traffic as well as discovery traffic and Consul template traffic. It's usually best to separate those admin domains out. So hope that answers that. It's a little bit of a long-winded answer.
No, thank you. I think that should be good on that front. Just checking to see if there are any other questions. I don't see any, but it does look like we are at time as well. So thank y'all very much for stopping by. I hope you had an absolute blast hanging with us today, getting to work through some demos. Hope that you have some new Consul use cases in mind and things to try out after checking out this stream. But feel free to reach out to myself. I'm at OnlyDole just about everywhere on the internet. And feel free to reach out to Cody or myself if you have any questions on this front, and we would be more than happy to chat with you more. Any parting words, Cody?
No, I love it. As you know, Taylor, I love working in the community. I love working with you guys and girls out in the audience. So like, if you want to reach out on Twitter, I'm at Cody D. Arkland. You see me ramble about Consul and Waypoint and Nomad and all kinds of random stuff. But this was a blast. Had a great time. Always fun hanging out with you, Taylor. Love it.
Absolutely. Thank you so much, Cody. Have a wonderful rest of the day, everybody. We'll see y'all soon.
Yes.